Hello guys, welcome back. So here we have another question on network theory from GATE EC 2016 and it is a very interesting question. In the circuit shown below, Vs is a constant voltage source and IL is a constant current load. So this is the circuit. So here we have constant voltage source in which has a series resistance of R and IL is your load. The value of IL that maximizes the power absorbed by the constant current load is dash. So we need to maximize the power absorbed in this load. So for that they're asking the value of IL. So we know the maximum power transfer theorem for a resistive load. So what does it say? So instead of a current load, if we have a resistive load, RL, the maximum power is transferred when RL is equal to R, right? And in that case, what is the current IL here? So IL is equal to Vs by 2R. And the maximum power transferred is Vs square by 4R, right? So here if we see, we get the IL value of Vs by 2R. But we still don't know that if for the current load also, if it is the same value. We can just make a guess with this. Maybe we are expecting IL is also Vs by 2R. So let us check that also. So we first need to find the power absorbed by this current source and then we will try to maximize it by taking the derivative of that. So if it is Vs and IL is flowing, what will this voltage be? This drop is IL into R, right? So this voltage is Vs minus IL into R. So what is the power across this IL? And we want only the power absorbed. Absorbed is equal to Vs minus ILR into IL. So it is the voltage across the current source into the current flowing through it. And for power absorbed to be positive, the direction is the current should flow from positive to negative terminal. So if you have any doubt, you can take for the resistor case. So here the current flows from positive to the negative terminal. So resistor always it is power absorbed. But for a current source, it can be power absorbed or delivered. So we need to ensure that this is always greater than or equal to 0. That is why if you see in this option infinity, so if you put infinity, this term goes to minus infinity, right? So minus infinity to infinity, it goes to minus infinity. But if you did not consider this sign, you might also directly choose this option as infinity. But for the case of infinity, your power is actually being delivered. See, if you see the power absorbed is negative, meaning the power is given by this IL. So the infinity cannot be an answer. So you should not be quick enough to tick infinity. Okay, so let us try to maximize this term. Okay, this we always want greater than or equal to 0. So this is nothing but VSIL minus IL square into R. So now let us take a derivative with respect to IL. So it comes as Vs minus 2ILR and this we want to equate it to 0. So what do we get? Your IL is equal to Vs by 2R. So by taking second derivative, can we also check if it is a maximum? If you see this is equal to minus 2R. So this is less than 0, which means that this point is a maximum. This is 2R, right? So this point corresponds to a maximum. So our value of IL is Vs by 2R. So whatever guess we made, Vs by 2R is actually the correct answer. So from this what we can infer is irrespective of the load being resistive or current source, the value of current for maximum power transfer is going to be same, okay, which is Vs by 2R.